Greetings to the viewer, this is Jashandeep Sethi right here, and today in this video I'll be solving question number 1 of MAT104 Endterm. Now since I don't have a tripod or any other means, I'll be recording this video on my phone while holding it in my hand. I'll try to keep it as stable as possible, so please bear with me. Yeah, so these are some prerequisites that I have written. In the question we have been given that the volume of the room is 20,000 cubic feet. We have also been given that the rate of inflow of fresh air is 600 cubic feet per minute. Also the rate of outflow of air is 600 cubic feet per minute. Another thing we know is that y y at time equals to 0, at time t equals to 0 is 0. Y being the amount of fresh air in the room at any given point of time. And for future reference we have taken log 10 as 2.302. So let me just write it down. Y is the amount of fresh air in the room at any given point of time. Then the change in the amount of fresh air in the room would be given by dy by dt, which is basically the amount of fresh air inflow minus the amount of fresh air outflow. So that is basically what gives us the rate of that is what basically gives us the change in the amount of fresh air in the room. Now we have been given the rate of inflow of fresh air, so that is basically 600, but we do not have the amount of fresh air outflow. But what we do have is the rate of outflow of air, not fresh air. So what we can do is we can divide this by the total volume of the room into y being the amount of fresh air in the room. So this entire term would give us the amount of fresh air outflow. So what we get is dy by dt is equals to 600 minus 600 by 20,000 y. Now on solving this further, we get 600 minus 0.03y. Taking 0.03y common, we get dy by dt equals to 0.03. Sorry, taking 0.03 as common, so we'll get actually we'll be taking minus 0.03 common. This will make it slightly easier for us. Y minus 20,000. So this is the equation that we'll get. Now we'll rearrange this equation, take the y terms on the left hand side and all the other terms on the right hand side, that is the dt term. We get dy by y minus 20,000 equals to minus 0.03 dt on rearranging the equation. Now integrating the equation on both sides, we get natural log of y minus 20,000 equals to minus 0.03 t plus c dash, where c dash is a constant. Now we take the log on the other side. We get y minus 20,000 equals to e to the power minus 0.03 t. Now this plus c dash, when it comes in the power, this can be rewritten as e to the power c dash. Now this entire e to the power c dash term is a constant, so this can be rewritten as c e to the power minus 0.03 t, where c is a constant that represents e to the power c dash term. So let me just rewrite this. Y minus, let me just write this completely, y minus 20,000, let me label this as 1. Now we know one thing, that Y, that is the amount of pressure in the room at time t equals to 0, is 0. So here we take time as t equals to 0 and we get Y as 0 minus 20,000 equals to C e to the power minus 0.03. Now since time t equals to 0, so this would be into 0. Now this entire terms becomes 0 and anything raised to the power 0 is 1. So what we get is C equals to minus 20,000. Placing this C equals to minus 20,000 in equation number 1, we get, just a second, let me just refocus this. Y, yeah, we get Y equals to 20,000 1 minus e to the power minus 0.03 t. We get this by placing C equals to 20,000, C equals to minus 20,000 in equation number 1, and by taking this 20,000 term on the right hand side. Taking 20,000 common, we get this equation. So now the question asks us that at what point of time will the volume of fresh air in the room be 90%. So we can find out the volume, 90% volume of the room, which is basically 20,000 into 90 by 100, which gives us 18,000. So the question is basically asking us that at what given point of time will the fresh air in the room be 18,000 cubic feet of fresh air. So placing this 18,000 cubic feet in this equation as Y, we get 18,000 equals to 20,000 1 minus e to the power minus 0.03 t. So we bring this 20,000 down, we get 18,000 by 20,000 equals to 1 minus e to the power minus 0.03 t. The zeros get cancelled and this is basically 9 by 10. Now on rearranging this equation, we get e to the power minus 0.03 t is equals to 1 minus 9 by 10, which is basically 1 by 10. Taking log on both sides, we get minus 0.03 t equals to log 1 by 10, which can be rewritten as minus log 10. Now if you remember, we had taken log 10 as 2.302. So here what we are left with is minus 0.03 t equals to, since we have a minus sign here, minus 2.302. So on rearranging, what we are left with is minus 2.302 upon minus 0.03. The minus signs get cancelled, and on solving this particular fraction, we get time equals to 76.73 minutes. So after 76.73 minutes, sorry. So after 76.73 minutes, the room will contain 90% fresh air. So this is a final answer. We started from here and we ended up with the final answer as 76.73 minutes. So I think so that is it, and thank you for viewing this video and have a good day ahead.